Before you get started today, I want you to stop this video and go get a piece of paper or a notebook or a journal, something that you can follow along in and write down answers on, because the more you write down today, the easier today's lesson is going to be. So pause the video, go get your notebook. All right, now that you have your notebook, please write down this problem that you see. You see 2.5 times 18. Now what I want you to do is I want you to pause the video again, and I want you to solve this problem. Any way you want, solve this problem. Okay, now that you've solved this problem, let's look at some strategies together. So one thing that you might have thought about doing is making an area model. That's where we're going to start today, is with an area model. So you can see here, I've drawn my area model. Okay, and remember, the area model is just using a rectangle or a banner shape or a flag shape, keep those in mind as we go along today, to help you solve a problem. So we've taken both of our factors and we've placed them along the width and the length of our rectangle. That way we know that we have to multiply them. Now, how does this area model or this array or this flag or this banner, how does this actually help me to solve the problem? One thing that I might have done is I might have taken it and I might have split it into two pieces. So we'll come back to this, but let's go to our area model now. So maybe I split this into two pieces and I think, well, this is 2 and this is 1/2. Now I know that I can multiply 2 times 18 and 1/2 times 18. Maybe you didn't think about multiplying it this way. Maybe instead you split yours up in a different way. So maybe you split yours up by cutting it here and saying this is 8 and 10. 8 plus 10 is 18. So now I have 8 times 2.5 and I have 10 times 2.5. Whatever way you chose to split this up is absolutely fine and can be really, really useful in helping us solve this problem. Let's look to this page. Now we see a way to solve this problem, and I'm going to focus on this one because I think that multiplying is hardest when I have to do it with fractions, okay? And you might agree with me. So let's talk about this, because we see we have a whole number and we have a fraction here. We have the number 2 and we have the number 1/2. Okay, together they make the number 2.5, and that's absolutely fine, but I like to multiply them separately just to make sure I don't miss anything. So as you can see, I've split my area model, split my rectangle into two portions. One of them is worth 2 and one of them is worth 1/2. Now, when I multiply those by 18, I get the answers that you see below. So we see that 2 times 18 is 36. That means I've solved this first portion. Then when I multiply 1/2 times 18, I know in my mind, I'm thinking, okay, well, I know what half of 18 is. Remember, of and multiplication, those words are the same. Half of 18 is going to be 9. Now, what if I wasn't sure how to do that? Well, I can think to myself, I know that a fraction is like the opposite of division. So I could take this and I could say, well, if I were to make this division, I'd be dividing by 2. So I'd have 18 divided by 2 equals 9. If you're like, whoa, that didn't make sense to me, totally fine. Stick with your multiplication here. Okay, both of those are excellent options. All right, so now that we have figured out that 1/2 times 18 equals 9 and 2 times 18 equals 36, then we can put them all together by adding these equations, and we find out that 2/2 times 18 equals 45. Okay, 36 plus 9 is 45. Now that we found that out, I'd like to go through a couple more problems. So this first problem I want to look at with you is, what is the area of a banner? A banner is like a flag. You know those things that hang in the gym that tell us about all the trophies that Lincoln has won? Those are banners, right? Or you know when you go to a airport and they have these big signs hanging that say like, this person donated this place, or something cool like that. Those are banners. They also look like flags, which is why I've written the word flag here, okay? So what is the area of a banner that is 1¼ feet wide and 36 feet long? Now we've written down the equation for you, 1¼ times 36, but I want you to pause the video and see if you can solve this on your own, maybe even trying to use an area model. Great. Now that you've solved it on your own, let's look at what I did. So I would like to draw a beautiful rectangle here. Now I see that I have a fraction, okay? I've got a mixed number. So I'm going to put my 1 here and my 1/4 here, okay? And then I'm going to split this into pieces. I know that this whole side is equal to 1 1/4, but I like splitting my fraction up. Then I'm going to write my other factor, 36, across the top. So now I know that I have two problems to solve, 1 times 36 and 1/4 times 36. 1 times 36 is easy. 36. Anything times 1 is itself. And then 1/4 times 36, I'm going to want to think to myself, what if I split 36 into 4 pieces? How much would be in each section? So I'm splitting 36 into 4 pieces, and I remember that 4 times 9 is 36. So I know that 1/4 of 36 is 9. Now I'm going to add these two together, right? I'm going to add my whole side together to create my entire area, and then I'm going to add them together, and I see that that is 45 square feet. Okay, remember we're doing width times length, so I'm going to have something squared, and it is feet, so I'm going to always label it. All right, so now that I've done this, maybe you solved it this way, or maybe you thought to yourself, well, I can just write the equations. So maybe you just wrote down 1 times 36, then 1/4 times 36, and then you solved just the same way we did with the area model, and you found the answer here, okay? If this is what you chose to do, that's awesome. Keep it up, okay? So let's take a look at another problem. Now, Caleb has an order for a banner that is 5 feet wide and 9 feet long. What is the area of this banner? You might be screaming at me, well, that's so silly, Miss Katie. We know how to solve that one, no problem, okay? Because 45 times 9 is 45. And remember, we're going to call this 45 square feet because we're finding area, okay? So check, we solved that one. So let's move on to the next one. Caleb got another order for a banner that is 4.5 feet wide and 10 feet long. What is the area of this banner? Now, how might you solve this problem? Now that you've taken a minute to solve this problem on your own, hopefully you see that you can solve it in the same way we did before. Maybe you just thought to yourself, well, I know 4.5 times 10. I know because of the rules of power of 10, if I multiply by 10, all I have to do is move my decimal and place 1 point to the right. So I know that this is 45 feet squared. Maybe you didn't feel comfortable with that, and maybe you thought, well, I could split this up into 4 and 0.5 and then multiply by 10. So 4 times 10 equals 40, sorry for my messy writing, and 4 times 0.5 equals, and I thought to myself, well, I like fractions better, so 4 times 1/2, which equals 5. Sorry, not 4, 10. 10 times 1/2, which equals 5, okay? So maybe you thought about it either of those ways, and if you thought about it some other way to solve, that's absolutely fine, but we're thinking about our rules of powers of 10. Now maybe you're starting to notice something. You're like, well, when we solved before it was 45, and now it's 45, and then we did this easy one that was 45, and then we solved this one which was 45. What is going on? Let's take a look at all of the problems that we solved together in a row. What do you see happening? What pattern can you recognize? Now maybe you're like me and you're over here and you're starting to look at all of these different factors and you think to yourself, well, half of 2 1/2 is 1 1/4 and double 18 is 36. So that's interesting, right? Half and double. And then I could do it again. I could think, well, if I do double 2 1/2, that's going to get me to that 5 times 9, right? So what I see is that I'm using my information to double and have our favorite strategy, okay? So no matter if my problem is being doubled and halved for my first factor or my second factor, I'm seeing this pattern repeated over and over again, showing me the same answer in square feet. Okay, so this is just a gentle reminder that doubling and halving can be a really effective strategy for helping us to solve problems with fractions. Okay, so let's take a look at these 3 problems. Pause the video and see if you can go solve the problems on your own. Now that you've paused the video, hopefully you thought for this first problem, what is the area of a banner that is 3 1/3 foot wide and 27 feet long? Hopefully you thought to yourself, well, I know that I can always rely on the area model. So I split this up into 3 1/3 times 27, so that I had the problem 3 times 27 and 1/3 times 27. Then you would have found out through your miraculous solving that 3 times 27 is 81 and 1/3 of 27 is 9. You would add those two things together and you would find that your banner's area is 90 feet squared. Okay? Now, maybe when you started solving this, you thought, well, I'm not going to solve that problem first. Maybe I want to solve this problem first because it looks super easy, right? What is the area of a banner that is 10 feet wide and 9 feet long? Well, that's pretty easy to me. 10 times 9 is 90 feet squared, okay? If you started to solve that one, maybe you started to think of our doubling and halving rules and you were starting to wonder, could this help me solve in any way? So let's just try it. Let's just see what happens. If I were to, let's say, if I were to double 9, I would get 18. If I were to halve 10, I would get 5. Now, this doesn't seem like it's going to get me to the place that I want to be, but I'm going to be a little bit clever and I'm going to think outside of the box. So I might think to myself, well, I know that 9 times 3 is 27, okay, times 3. So what is 10 divided by 3? Now, if I think about 10 divided by 3, I could do the math and I would come up with 3 1/3 times 27. So I can find out that not only does doubling and halving work, but so does tripling and untripling? Not sure what to call that, but it's kind of a cool concept that we can think about as we solve problems. Now, let's look at this last problem. What is the area of a banner that is 3 1/2 feet wide and 12 feet long? Okay, maybe you thought to yourself, I know how to solve this by splitting up 3 1/2 so that I have 3 times 12 and half times 12, and I use my partial products, and it's awesome. And that is a really super duper strategy. I love it. But maybe you have thought about doubling and halving, and you thought, well, 3 1/2 times 12, I can halve 12 to 6, and I can double 12 to 7. And then you would have the problem, or double 3 1/2 to 7. And then I'd have the problem 7 times 6, which equals 42. So all of this is to say there are a lot of different strategies that we can use to help us find the area of a mixed number times a whole number. Okay, so that's what we're going to be practicing for the remainder of our lesson. Today we're going to be helping out our friend Caleb, okay? Caleb designs and makes flags as well as banners in his shop. Right now he is planning to make a flag that is 1 1/4 feet wide and 2 1/2 feet long. Remember, I'm reading the directions, I'm underlining important information, always do this. He needs to figure out how many square feet of cloth it will take, okay? So this is what I need to know and this is what I already know. What expression would you write to represent this situation? Well, I know that I need to find area, and an expression doesn't have to have an answer, so I'm just going to take my information, 1 1/4, and I'm going to multiply it by 2 1/2. This tells me what I have to do. Now I'm going to think about my estimate. What would be the most reasonable and why? Now, I'm making an estimate. It doesn't have to be exact, but I'm going to look at my numbers and think, well, I know that 2 times 1 is 2. This is what I'm thinking. I don't have to write it down, but maybe it'll help if I do. But then I also know that I have a half times a fourth, and I have all this other pieces, so it's definitely going to be more than 2. So what would be most reasonable? Do you think it would be most reasonable to say that it would be 2 or 3? I think it might be more reasonable to say 3 because we don't want him to underestimate and not have enough cloth to make his shape, make his banner. Now, let's look at question number 3. Here's the plan Caleb has sketched out for his flag. Use his sketch to solve the problem. So, Caleb has given us this awesome area model, and he split his 2 1/2 and his half into 2 and into half, and he split 1 1/4 into 1 1/4. So now, all I have to do is solve. This, in this quadrant, I would have 2 times 1. In this quadrant, 2 times 1/4. I like to write all my expressions so that I don't miss anything. In this quadrant, I'd have 1 times 1/2, and in this quadrant, 1/2 times 1/4. Okay, so now that I've got all my expressions written down, all I have to do is solve. Okay, so maybe I'll write them neatly in a line so that I know that I haven't missed anything. Okay, and then I will solve them all so that I have the information all in the same place. Okay, so let's start with the easy one. 2 times 1, 2. 1 times 1/2, anything times 1 is itself, so has to be 1/2. 2 times 1/4. How do I solve this one? If we remember, we can think of this as like 2 over 1 times 1/4, because every whole number is over an imaginary set of ones, right? Always they are. That's what it means to be a whole number. And then we can think I just multiply straight across, so I get 2/4. Okay, so I'm going to place my answer 2/4 here. And then I have this problem, multiplying two fractions. Now, if you are like me, you're like, oh yeah, I just multiply numerator times numerator, denominator times denominator, and I'm super happy. But if you're not, it's okay. Let's look at another way we could think about this just to serve our little reminder. When I multiply these fractions together, I might think of a geoboard, okay? So I think of my 1/4 section times my 1/2 section, and then I'm going to just draw my array out and see, okay, well, how many sections of this size could I make here? I could make 8 of them. And if I could make 8 of these sections, then that means that one of them is going to be equivalent to 1/8, okay? Now that I have all this information, what do I need to do with it? Can I just leave the answer like this? I can't, right? I can't leave the answer like this, so I'm going to have to add all of that information together. Here we can see all of that information neatly together, all of my different equations, and then my final equation where I add all of that information together, okay? So I have 2 plus 1/2 plus 1/2 plus 1/8. To solve this problem, what I would want to do is I would think 2, and then I know that 1/2 plus 1/2 is equal to 1 plus 1/8, and then lucky me, doesn't have to do any common denominator finding. However, if I'd had to find common denominators, let's say I had wanted to do it first, I could have figured out that 4/8 is equal to 1/2, so I'd have 4/8 plus 4/8 plus 1/8 equals 2 and 9/8, and then I know that this is equal to 1 and 1/8, so that's 3 and 1/8. Okay, so any way that you're solving this problem is absolutely fine as long as you're getting to the same answer and you're showing your work. Today you will be helping Caleb solve for more areas and dimensions of his flags on these 2 pages that you see here. So make sure that you read the directions first, figure out what am I being asked, what do I need to do, what do I know, and what am I trying to find, okay? Answer those questions and then you'll be able to solve these problems. Good luck and have fun finding those banners.